Hello everyone, this is our 44th video tutorial under the GCSE topic revision guide called Iteration. In our last video, we have learned how to use the trial and improvement method to find out a particular solution for an equation. That solution is going to be an estimated one because it's a kind of a solution between 2 points, and then we are going to find out another solution, and we keep on doing this one substitution and trial and improve our method to find out the solution. But in iterative process, we are going to do the iterative process numerous times until we get the accurate solution. The more you do the iterative process, we get the accurate answer. Let's look at the theory, and we are going to do the exam style question to understand what is the iterative process. Hello everyone. This is the tutorial we are going to discuss in this video session. You can download this tutorial from our website at www.smart-tutors.co.uk/worksheet.php. Under the Year 11 section, you can download this tutorial. The annual membership costs £24, monthly roughly £2 per month, which allows you to download all the video tutorial in a PDF format, and also we are posting our predicted papers and the past papers in a PDF format also. Let's look at the exam style question. Question number 1. Using xn plus 1 equal 8 minus 5 over x squared n with x0 equal 1, find the values of x1, x2, x3, x4. Right, so this is the equation we are going to use for the iterative process. Right, we call this x0 equal 1 is the starting value. We call this as a starting value. I'm going to be explain the topic in this question. So in the question number 2, I'm going to be do it a little bit faster. So I'll spend some time to explain what is this iterative process and how to do this one. Then after that, from the question number 2, I will catch up my time and make sure the video fall under the specific time. Right, this xn plus 1 equal 8 minus 5 over xn squared, which means this n plus 1 is the value after the xn. So if you think about xn and xn plus 1, n and n plus 1 is the one term after. So if this is x0 and this is going to be x1, if this is x1, this is going to be x2, if this is x2, this is going to be x3, right? So if xn plus 1 is the next term, so starting value x0 is given. So if you put the starting value here as a x0, this is going to be the x1, right? Then once you find out the x1, you can repeat that one substituting x1 here, then you will get x2 here. Then find the x2 and come and substitute here x2, and you will get the x3. Then you substitute the x3 here, then finally you get the x4. More you do this iterative process, more accurate answer will obtain for the particular solution. Let's look at this one. Right, x0 equal 1. So if I want to find out x1, which is 8 minus 5 over x0 squared, which is 8 minus 5 over 1 squared. The answer is 1 squared is 1, 5 divided by 1 is 5, 8 minus 5 is 3. That is the x1 answer. x2 is equal 8 minus 5 over x1 squared, which is 8 minus 5 over 3 squared, which is, we have to use the calculator to obtain this answer, right? The answer is 8 minus, I use this fraction sign, 5 below 3 squared, and equation is 67 over 9, and the answer is 7 recurring. So 7 is recurring, so 7.444 dot 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 dot, right? So you can put 7.4 recurring, right? X3 is 8 minus 5 over x2 squared, which is 8 minus 5, 7.4 recurring squared equal. So the beauty is the answer you get is going to be stored under the calculator's memory. So if you press answer and you get the answer there. So how you're going to use this one? So 8 minus fraction 5 over answer squared equal 7.909. So 7.909. So let me call the calculator again. 909 779461. 779461. So leave it like that. Then final answer x4, it's going to be 8 minus 5 over x3 squared equal 8 minus 5 over 7.909 squared. This is dot dot dot. Then the answer is, we're going to use the calculator 0. So 8 minus 5 7. Oh no, I'm not going to use the 7. I'm going to ask the answer square. So which is 7.9200826617. 7.92 7.92 82617, right? So those are the 4 values for the answer. So more you do, so the final answer can be one of the solution for the initial question. So initial question is actually x equal 8 minus 5 over x squared. So the solution for this equation, this could be one of the solution, right? So starting value they will give, and after that you need to keep on increase the value by 1 and use the calculator's memory to keep the answer in the memory, then recall and do the question. So this is called iterative process, right? Let's look at the question number 2. Using the x n plus 1 equal 8 over 9 minus x cube n equal over 9, starting value is given, find the x1, x2, x3, right? So I'm going to do the x0 equal 0, x1 equal 8 over 9 minus x0 cube over 9, which is going to be 8 over 9 minus 0 cube over 9. So the answer is 8 over 9. That is going to be 8 over 9 is going to be, so 8 divided by 9. So we keep that as a decimal recurring 0.88888. That is the answer. So 0.8888 recurring, right? So x2 is going to be 8 upon 9 minus x1 cube over 9. 8 upon 9 minus 0.8 recurring cube over 9. So that is going to be, so the answer is 8. So 8 divided by 9 minus 0. Answer, so I'm going to call answer cube and 9. So the answer is 0.810852, 0.810852, 0.810852. So that is the x2. x3 equal 8 upon 9 minus x2 cube over 9. So which is going to be 8 upon 9 minus whatever the answer. So 0.810852 cube over 9. So again, the calculator will remember the answer of the previous step. So if you are in doubt, if you press the answer equal, that is the answer of the previous step. So you do the same thing. Fraction button 8 over 9 minus answer cube 9, and the answer which is going to be 0.829653, 0.829653, 0.829653, right? The last answer, x4 equal 8 upon 9 minus x3 cube over 9 equal 8 upon 9 minus 0.829653 to the power cube over 9 equal, right? So that is going to be 0. So fraction 8 over 9. So 8 over 9, and that is going to be answer cube and divide by 9. 0.825436, 0.825, 0.82546 dot dot dot, right? So those are the final step they asked for. So x1, x2, x3, x4. So make use of the calculator and keep the memory and repeat the answer again and again to find out their final answer. Question number 3. Show that the equation x cubed plus 2x equal 1 has a solution between x equals 0 and x equal 1. So the method what we are going to use is, let's say I bring x cubed plus 2x minus 1 equals 0. This is the equation. When I put x equals 0, let's say this is a fx function, right? If I put 0, 0 cube plus 2 times 0 minus 1, so the answer is minus 1. X equal 1 is going to be 1 cube plus 2 times 1 minus 1 equal. So 1 cube is 1 plus 2 minus 1. So 2 plus 1 is 3, 3 take away 1 is 2. So this is a negative answer, this is a positive answer, right? So there is a sign change, right? So there is a sign change, there is a sign change for the values, for the x values of x equal 0 and 1. Therefore there is a solution between them, right? So how it is actually, if it is a graph here, and if the graph is having a x equals 0, there is a negative value, and x equal 1, there's a positive value. So the curve is definitely going there. So it is definitely cutting the x-axis at one point. That is we said as a solution. Sometimes we called as a root. So what did I said? X equals 0, there's a negative value. X equal 1, it's a positive value. And the curve is going through these 2 points. Definitely it cut the x-axis where it's the solution. If a graph cutting or just passing through x-axis, that is we called as a root. Root mean is a solution. So in this question we have proved there is a solution between 0 and 1. Question number B, show that the equation, this one, can be rearranged to that one. So x cube plus 2x equal 1. If you carefully see, the x cube is other side. So you take away x cube both side. So you will end up with 2x equal 1 minus x cube. Then you divide by 2 both side. And this is going to be x equal 1 upon 2 minus x cube over 2. So that is the answer for the question number B. Question number C, starting value is given x0 equals 0. Use the iterative formula, which is xn plus 1 equal half minus xn cube over 2 twice. So you need to do 2 times. So you need to find the x1 and x2, that is more than enough, and estimate for the solution this one. That is the solution for the previous equation in the part A. So you do the normal bits in the iterative process twice, 2 times, then you will get an answer for x2. That is going to be the estimate solution for the previous equation. Let's start. So x1 equal half minus x0 cube over 2. x0 cube is 0. So half minus 0 over 2. So the answer is half, which is 0.5. x2, that is the last answer, half minus x1 cube over 2. Half minus 0.5 cube over 2 equal, right? So the answer is going to be, right, so I'll put the calculator here. So 1 over 2 minus 0.5, so 0.5 cube to the power 3 over 2, and the answer is 0.4375. So 0.4375. So you can say x equal 0.4375. It's an estimate solution for x cube plus 2x equal 1. Question number 4. Using x n plus 1 minus 3, everything is given. So they are asking the value x1, x2, x3. Let's start with this one. x1 we already know now. So minus 3 minus 2 over x0 squared, which is minus 3 minus 2 over minus 3.5. Put them into the bracket because it's a negative value, equal that one. So x2 equal, what's going to be happen? Minus 3 minus 2 over x1 squared. So minus 3 minus 2 over the previous answer, I don't know what is that, so that squared. So x3 equal minus 3 minus 2 over, here 3 means this is going to be x2 squared. So minus 3 minus 2 over that previous answer squared. So these are the answer we need to find using the calculator. That's it, right? So use the calculator. So put the answer somewhere here, right? So what's going to be happen now? So let's start with this one. So minus 3, right? Minus 3 minus, and the fraction sign 2, and bracket start, minus 3.5 bracket close, and squared, and the answer is minus 3.163265. Minus 3.163265. and dot 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 dot. So you can copy the entire calculator. Let me check one more time. 163265. Very good. So the answer is saved in the memory. So we are going to use the calculator again. -3 minus again -2 minus is already there, so 2 answer. That is the beauty about this one, answer squared, and press the calculator, and that is going to be -3,199,875 -3.199875, and that is recurring. Next one, again -3 minus fraction and 2 over and answer squared, and -3,195,328 -3,195,328 dot dot dot. So that is the answer, -3,195,328 dot dot dot. So that is the answer for the question number 4. Question number 5. Show that the equation x4 minus 5x plus 1 has a root between 1.5 and x equal 2. So we are going to use the same technique. So if I assign this as a fx, so the fx equal x4 minus 5x plus 1, right? And if I substitute fx as 1.5, what would be the sign? 1.5 to the power 4 minus 5 1.5 plus 1, and try to find out the answer, positive or negative. F of 2 is 2 to the power 4 minus 5 2 plus 1. Try to get the answer whether positive or negative. If there's a sign change, there is a solution. If not, there is no solution. Let's quickly do that one. So 1.5 to the power 4, and the next one is minus 5 times 1.5 plus 1 equal. The answer is minus 1.4375. Minus 1.4375. The next one, it's going to be 2 to the power 4, 16. I know that. Minus 10 plus 1, 6 plus 1 is 7. So the positive answer is coming here. So there is a sign change. Therefore, there is a solution for equation x to the power 4 minus 5x plus 1 equals 0 between x equal 1.5 and x equal 2. So that is the answer for the A part. B part, use the iterative formula x n plus 1 equal cube root of 5 minus 1 over xn 3 times starting value is x0 equal 1.5 to find an estimate solution for this solution. So basically we need to find out x1, x2, x3, then conclude the answer. x1 equal, we know, cube root of 5 minus 1 over x0, which is cube root of 5 minus 1 over 1.5. The answer is right. So cube root, so what we are going to do, the cube root is shift and this button, cube root of 5 minus fraction button 1 over 1.5. So that gives an answer 1.630324. 1.630324. So the answer is 630324. So if you do the second time is x2, its cube root of 5 minus 1 over x1 equal cube root of 5 minus 1 over 1.630 dot dot dot. So the answer is I can go and change this one, right, as a cube root of, so I can change this as an answer, and now 1.636980. So 1.636980, 1.636980 or 6, I'm not too sure. Let me check. 980. Very good. Now final answer, x3 is cube root of 5 minus 1 over x2, which is cube root of 5 minus 1 over 1.636980. Right? So the answer is, it's easy. You don't need to do anything, just to go and change the answer again, delete, and put the answer back again, and equal 1.637290. 637,290. 637,290. That is the answer. So they ask you to do 3 times. We have done 3 times. So the estimate answer is x equal 1.637290 is the estimate answer. Estimate solution, if you put solution for the equation. So if you write that one, you'll get, so if this is coming in a GCSE, you will pretty much get 5 to 6 marks, because there's a lot of work, a lot of calculation, time consuming. And last question, I believe, question number 6, using the xn plus 1. So x0 is a negative value. Let's do this one. So x1, how you're going to do, minus 7 plus 20 over x0 squared. So which is going to be minus 7 plus 20 over minus 9, put them into the bracket, squared, equal. So x2 equal minus 7 plus 20 over x1 squared, equal minus 7 plus 20 over the answer, whatever the answer, that squared, that is the x2. And x3 is going to be minus 7 plus 20 over x2 squared, equal minus 7 plus 20 over the whatever the answer on the previous step, that is the answer. It's a matter of pressing the calculator, but you need to be cleverly use the calculator to save some time. So let me do this question quickly with the scientific calculator here. So minus 7 plus a fraction 20 on the top, and now minus 9, so minus 9 and squared, right, and that is going to be minus 6,753,086, minus 6,753,086. Is it right? 086. Yeah, that is the memory. Right, now what we are going to do is everything same. So I'm going to change only the inside answer. That is going to be answer, whatever the minus will capture there. So minus 6, 561, 144. Minus 6, 561, minus 6, 561, 544. If I'm not capture the correct answer, I will correct it in a minute. 561, 443. Sorry, 561, 443. So this is wrong. 561, 443. right? So this answer will come there as an answer from the previous step, and that answer will go here, answer as a previous step, and the final answer is going to be the next calculation. So I delete everything and delete this as well. If you want to put the answer back again, calculator will remember only the last answer. Minus 6, 535, 451. 535, 451. So minus 6, 535, 451. Assuming that is correct. So 535, 451. That is perfect. So you can write all the displayed answer technically. So your calculator's displayed answer, you can write everything, and that is going to be the solution. There's a question number 7 is there. Let me check. That is the last question we are going to do. So let's do the question number 7 here. Show that the equation has a solution between x equals 0 and x equal 1. So I'm going to be rushed on this one. So when I bring the x cube here, 4x minus 1 equals 0, I'm going to assign this as a fx. When I put f0, x equals 0, what will happen? 0 cube, 4 times 0 and negative 1. So it's everything there, so minus 1. So if I put f equal 1, that is going to be 1 cube, 4 times 1 minus 1. So 4 plus 1, 5, take away 1 is 4, but it's positive. So there is a sign change. There is a sign change. There is a sign change. Therefore, there is a solution. There is a solution between 0, 1. Show that this one can be rearranged. So what you're going to do, so x cube plus 4x equal 1. Take away both sides x cube, so 4x equal 1 minus x cube. X equal 1 upon 4 minus 1 upon 4 x cube. So that is the answer for the question number B. Question number C, starting with x0 equals 0. So x0 equals 0. Iterative formula is given. So xn plus 1 equal 1 upon 4 minus xn cube over 4. They ask you to do twice, so you need to find a solution. So x1 equal 1 upon 4 minus x0 cube over 4, so which is 1 upon 4 minus 0 over 4 is 1 upon 4 is 0.25. x2 equal 1 upon 4 minus x1 cube over 4, so 1 upon 4 minus x1 cube is 0.25 to the power cube over 4. That is going to be the answer, because they ask you to do only 2 times. So press the calculator. So 1 over 4, which is we know 0.25, minus, and a fraction sign, 0.25 to the power cube, and below is 4, and that is the answer, 0.246093. 0.246093. So that is the answer for the question, right? I hope you understand the method using iterative formula and using the iterative process a couple of times to get an accurate answer for the given solution. You can download this PDF file from our website if you like. Subscribe to our channel, which costs you monthly £2, which allows you to download all the predicted papers and all the topic revisions guides in a PDF format, and the past papers also. Thank you for watching the video. If you like the video, please give us a thumbs up and subscribe to our channel for upcoming video. Thank you so much.